Good morning. My name is Dr. Oda Srinivas Rao, Department of Computer Science and Engineering. My subject is mathematical programming. Today my topic is indefinite dimensional optimization, session 23 and 24. The aim of this session to familiarize students with the basic concept of infinite dimensional optimization, their formation and solution. The objectives of this topic, the section is designed to demonstrate infinite dimensional optimization, its a formation and types of indefinite dimensional optimization, solution of indefinite dimensional optimization problems by different algorithms, and after completion of this topic the students learning outcomes are understand the indefinite dimensional optimization and its types, their possible applications in real world problems. After completion of the topic, now we can go for the introduction of the indefinite dimensional optimization. Infinite dimensional optimization is a field of mathematical optimization that deals with problems where the decision variables are functions rather than finite dimensional vectors. These problems arise in many areas of science and engineering such as optimal control, image and signal processing and machine learning. One of the main key challenges in the indefinite dimensional optimization is the fact that the space of the functions is a infinite dimensional and does not have a finite basis. This makes it difficult to formulate and solve the optimization problems analytically. The main reason here we define the space of the function is very difficult. Why? Because it is a indefinite dimensional optimization. And the second point, the objective of the indefinite dimensional optimization is as usually a functional that maps a function to a scalar value. The decision variables are functions that satisfy certain constraints, which may be in the form of differential equations, integral equations or inequalities. For example of the infinite dimensional optimization, consider the problem of finding the function that minimize the following functional. G of y is equal to integral between the interval 0 comma 1 of y of x square plus y dash x square dx subject to constraint y of 0 is equal to 0, where y of x is a function defined on the interval between 0 comma 1 and y dash of x is the first derivative. This is an example of an infinite dimensional optimization problem, as the decision variable is a function y of x that can take on an infinite number of values. The objective function g of y maps the function y of x to a scalar value, and the constraint specifies that the function must satisfy a certain condition at the point x is equal to 0. The main goal is to find the function y of x that minimize the j of y subject to constraint. This problem is an example of variational problem, and the solution can be obtained using techniques from the calculation of the variations. And the next topic in the indefinite dimensional optimization, the heuristic functions and meta heuristic function. The first one is the what is the concept of the heuristic? The heuristic are the simple and practical problems specify the techniques that are based on the rules of thumb or common sense. They can provide a good solutions quickly but are not guarantee to find the optimal solution. Some examples of the heuristics including greedy algorithms and hill climbing and tap charts. For example, a heuristic algorithm might be used to find the shortest route between the two cities by considering only the immediate neighbors of the each city. And meta-heuristic concept is defined here. Meta-heuristics are general purpose optimization techniques that can be applied to a wide range of optimization problems. They are designed to explore the search space efficiently and intelligently, and then can often find a good solutions even in a large and complex optimization problems. Some examples of meta heuristics include simulated annealing, genetic algorithms, and practical SWAM optimization. For example, a genetic algorithm might be used to optimize a manufacturing process by evaluating a set of the process parameters over time. Next point we are discuss about the single solution related to single solution versus the population based solution. What is meant by the single solution in indefinite dimensional optimization? Single solution approaches focus on finding a single best solution of the problem. They start with an initial solution and iteratively improve it until no further improvement can be made. For example of the single solution approaches are the gradient based methods and local search algorithms. For example of the single solution, a gradient based method might be used to optimize the design of a wing by the iteratively adjusting the wing shape until the lift to the drag ratio maximized. The next one is population based approaches. Population based approaches maintain a population of the candidate solution and evaluate the population over the time to find the better solution. For example of the population based approaches are genetic algorithms, practical SWAM optimization and anti-colony optimization. For example, a particle SWAM optimization algorithm might be used to optimize the financial portfolio by evaluating a set of investment strategies over time. And parallel meta heuristic concept are also defined here. The parallel meta heuristic are a class of meta heuristic that can exploit the computational power of parallel computing architectures to speed up the optimization process. Parallel meta heuristic can be implemented using different parallel computing architecture such as a multi-core CPUs or clusters and GPUs. And parallelization can help to speed up the optimization process by allowing multiple candidate solution to the evaluating simultaneously. Some examples of the parallel meta heuristic include the parallel genetic algorithms and the parallel practical SWAM optimization. And for example, a parallel genetic algorithm might be used to optimize a large scale supply chain by valuing a set of logistic strategies over a time. After completion of the above topics, one is the heuristic concepts and the second one is the meta heuristic, single solution and parallel based solution, we are define the some self-assessment questions. The question number 1, which of the following is an advantages of using meta-heuristic methods to solve the infinite dimensional optimization problem? And second one is, which of the following is a disadvantages of using heuristic methods to solve the indefinite dimensional optimization question? After completion of the self-assessment, now we are defining some of the terminal questions. Are one is what are the some common heuristic approaches to solve the indefinite dimensional optimization problem, and how do they compare in terms of efficient and accuracy? How can meta-heuristic algorithms can be used to optimize infinite dimensional problems with nonlinear constraints, and what are the sum of the trade-offs involved? What are the some of the advantages of using single solution methods such as the gradient descent or Newton's method to solve the infinite dimensional optimization problems compared to heuristic or meta-heuristic approach? And next question, how can population based methods like genetic algorithms or practical SWAM optimization be used to solve multiple objective indefinite dimensional optimization problems, and what are some of the challenges involved in implementing these algorithms? And next question, what are the some of the key consideration when choosing between the different optimization methods for infinite dimensional problems, and how do this consideration differ depending on the problem at hand? And some of the reference textbooks and online websites are there. And thank you very much. My topic is indefinite dimensional computation related to the CO4.